Hi everyone, welcome to the third chapter of Wearing Flip-Flops. I'm Ronan, your host, and with me, Yaron Ilani.
Hey guys.
And we have again our special guest, Claudio. We haven't had the chance to finish our contestation last week. So let's dive into some more questions that we had.
Let's dive, guys.
We talked about the sizes and the scale of the chips. We talked about the verification plan, the strategy. But we also touched that there are different teams. So prototyping, emulation, formal, verification, cluster, block level, full chip. Can you say how do you guys work as a team? And are there any things that you guys do together, or each of you working in a silo?
No, so that's a good question because on top of what you said, we have also physical design team that we work also with, and we have also software guys that are a part, really a part of us, right? And yes, it's a challenge. You have to make small groups that will be focused on different subsystem or areas in the design, and there is one owner that will drive this small team. A small team, I mean, it's not so small, but we try to be like between 6 and like 8 people or something like that.
I think AWS likes to say pizza size, right?
Pizza size, yes, but it depends. So the thing is that when you have small groups, then you can, and you have an owner that you can trust that knows how to synchronize all those things. You have one owner, like I said from the beginning. It's all about mindset. At the end of the day, you have to trust the people that have ownership, see the full picture, think big, dive deep on the other side, and deliver results with highest quality. This is all you have to have.
I'm the block level guy for a few blocks. And I'm not at AWS. I just run the blocks, and what do I care about the full chip at this point? Why do I care about the emulation? Do I really have to have interaction, or would you, as the overall owner, dive into what each of us are doing and make sure that we do the things that help us both? Or each.
So first of all, we don't want dependencies, right? So I don't want now that the unit level guy will think what the emulation will do, but he has, at the end of the day, let's say if you are owner of a block, right, and you want to do sign off, you have to, when you do sign off, you don't do for the DV, you do together with what was done in emulation, what was done in full chip simulation, what was done in block level, what was done in any informal verification, right? So there is no such a thing.
As a block owner, you are the owner of the block from
across
your level
the board
up. But then you have,
yes.
Each team should be the owner, right? What about the
that's
emulation
fine.
guy? So everyone is the owner?
Yes.
No one owner?
Yes, no, there is one owner. No. It isn't, because you have one owner that will do the sign off. And he needs to make sure that all of the way, but it doesn't mean the emulation guy now, okay? Let's say if the emulation guy is the owner. Let's say he's the owner. So he needs to make sure that everything that was planned to be done in formal verification was done, and it's covered, and we got what we wanted to get there, if it's foolproof or maybe not foolproof, just coverage. So if you are the owner, it doesn't mean the others doesn't have their own ownership on what they are doing. That means that from my perspective, right, I cannot, talk to, I do that, but let's say I will not, if the scale will go and will continue to grow, there is a limit with how many people I can, synchronize simultaneously. So I need to have people I can trust that will do what I did 2 years ago and 4 years ago and stuff like that. This has to, to make a scale, you have to do that.
Let's talk about the life cycle of a project, like the day-to-day of what each of the teams are doing. Let's maybe split that in the first 3 months and then talk about, after that till the tape out, if there's any difference.
There is a difference, right? For example, Not always, it depends, but in most of the cases, like unit level will finish its work, earlier, and formal verification also. They work like mostly in parallel, right? And full chip will continue to tape out, right? And
Do you start the full chip with the block level and with the
yes,
emulation, or just
yes, all in parallel, multiple
how do you do
threads.
that? I mean, do you have the things ready for emulation at day
It
one?
depends. First of all, to bring up the emulation, a lot of time you have issues with bring up the model and the compilation stuff and stuff like that is even not related to functionality. Connect all the devices that you need externally, and a lot of times, by the way, because let's say you have a unit level in UVM and you have VIPs to connect to your device, right? And sometimes you have issues with the environment, verification environment stuff that your VIP doesn't work as you expected, and you debug it with the vendor. In emulation, there is a lot less things to deal that are verification environment issues. There are
Some would
less.
say, Claudio, some would say that for emulation, since if you need to run software and stuff, so if the DOT is not mature enough, thing would, break at time zero. I mean, you
Right.
can't really do that. So, are you saying that you cope with the environment issues and then wait, or
No.
just
So there is a synchronization, right, at the project level that we are seeing, okay, if the chip doesn't get out of reset in full chip and there are real issues in the RTL, of course, I will go to emulation, I will get the same. So there is no point to do that, just in the sake of doing that. So we do synchronization meetings that we look at all, from block level. We see what happens in the full chip, in subsystem, if there is a subsystem in the middle, right? And we do checkpoints. It's on weekly basis. We are not just taking and, in the sake of doing things in parallel, we cover our eyes and go forward without checking. No, we do have synchronization.
And if we look about, block level and cluster level and full chip level tests, can you estimate, how much time a test runs, compiles and runs in each of the categories, let's say in the first 3 months?
It depends because we have a lot of configurations to the environment. Okay, even if in the full chip, we have an environment for development that runs relatively fast, right? We
Let's talk
can
about,
be
80-20 rule, what's the
let's
massive
say
and the
let's say the fastest test in full chip will run like 1 hour and a half, 1 hour, right? Which is fast. It's not
Wow,
something
it's not
very
too
fast,
bad.
right?
Do
Not
you
too
have
bad.
any tricks to shorten the simulation time? Like,
Of course we do, but we won't tell.
no, just yeah, of
No, just
course.
kidding.
Since
Yes, we do. We do. We use also,
you force like configurations, you skip
we
resets
have
and PLL stuff, and
we do not skip resets because it won't work. But we do have shortcuts in the design. But not only in the design, we do smart like backdoors, like you said, in places where we can. But it's also like we split the chip. We have the full chip, but you don't have to have the whole blown all the time, right?
right.
So
So you do like
we do
flows, like end-to-end
exactly.
flows, but orthogonal flows, and then when you,
Exactly.
yeah.
Yeah. So I
That's a
don't
good
So
want to
approach.
get
one
to
and a
the details of that,
hour,
but yeah.
1 hour, 90 minutes for, the shorter test in full chip,
And you get
up.
to the longest test, you can go to a week, if you want to do a stress test in simulation.
This is RTL, right? Not
RTL, only
SDF
RTL.
or okay.
Gate level, it's a different story.
Yeah.
And in gate
So
level, by the
with
way, we have a very special technique that, it's currently in a patent process that we developed here. So, yeah, because if you think about a full chip and run this kind of full chip, and you can imagine, right, the size of it, it's not feasible to run netlist, full netlist on that, and definitely not SDF, right? Definitely not SDF, which is at least 10 times slower than any gate level. Actually, I might say, I don't know, because I cannot say all the industry, because I don't know all the industry, but as far as I know, I don't think this technique is used anywhere.
Okay, we'll probably
Still,
host you
but
again after the
I must be
patent is
humble
out.
because there are many smart people, in this industry that probably doing also smart things.
Claudio, so you said, 90 minutes to a week. Most of the tests in the first 3 months for cluster or full chip, would those take half a day, a few hours, on
Few
average?
hours, I think. Few
Few hours.
hours. Few
And what
hours. Yeah,
happened
I would say.
after? What happens after 3 months?
You say 3 months, it depends, but let's say 3 months, okay? And then we start to ramp, the more exhaustive tests, right? And the exhaustive tests, if I develop tests, I do it in a small model. Anyway, the tests will run exactly the same it should be run exactly the same when I run it in a larger model. And if it fails, I need to debug. But I will run it, I will not run it during the day and wait for it to get finished unless I need to debug, and this is what I do. But in general, the long tests that are exhaustive and doing stuff like that, they are running, in batch mode, and if they fail, they rerun automatically, and we get the waves dump and the logs and all the stuff. So we don't really spend time in waiting, but I cannot say that it cannot happen, right? It can happen.
Let's
But
talk about
it's
pain points. So for you, if you had to pick, two pain points that, keep you, I wouldn't say up at night, but bother you the most in the verification process as it is today, what would those be?
I think that I think if you look at the verification in general, right, and you want to solve the most time-consuming problem, it will always be debug. Always be debug, right? If you take how much code, even if you write an environment from scratch and you do everything, the debug will take you anyway more time than coding. So if debugging, and I'm not talking about just RTL, and definitely gate level, and definitely SDC, which is not an easy debug. It's not, the straightforward verification, standard verification guy to debug SDC failures. It's a different story. It's a different approach. It's a different world. You have to understand a little bit backend. So if my approach, for example, in using AI, I think it's, doing it with documentation and creating strategy from mass or creating
I'd like
test
to
plan.
touch AI actually right after this question, but let's focus on, you mentioned that the biggest pain point is debug faster, right? Is there another big pain point around that? For example, is runtime something that bothers you?
If I could run, I'm a software guy in my background. I'm a bachelor of computer science, so I used to write, a software that you compile, press the button, and you see the result. So I wish I would have a simulator that I press the button and I see the result. So this is something that we would really, I always thought about, what will be the solution, how do I make a CPU that all it knows, it gets a simulation image, right? A simulation image and runs it in seconds. But that's I think it's, if I could save the runtime, right? It would be huge because, if you think about the long test, if you talk about the 1-2 hours test, also if you save 1 hour test and you do it in 1 minute, you save a lot, right? 60 times. So if you take something that runs a week and you minimize it to like 10 minutes, then you saved your life.
Would you say that nowadays, because of the growing complexity, more workloads are shifted towards FPGA and emulation?
So first of all, yes, we use mostly emulation, right? But
What do you mean mostly?
we don't use FPGA as far as I'm concerned to it. But anyway, if you think about there is so emulation. It's great, right? It's fantastic, but it's much more expensive, right? So you don't have endless resources for that, and also simulation you don't have endless resources. It's never endless, right? But you have much more.
Yeah.
And also, if you look at so today in emulators, you have debug capabilities like you have in simulation, but you do have things that are not existing in emulation. For example, if you want to check CDC, There is no way to do it in emulation, for example. And if you want to check RDC, you can check it in emulation. So even if you have like a lot of resources,
CDC,
you still need
clock domain checker,
clock domain cross. Yes.
Cross domain, clock
Yes,
domain
cross
crossing
domain.
and reset
and
domain.
RDC.
Exactly. Yes. So these kind of things you don't have. Also, there are other things that I don't want to get into it too much details, but simulation is still not something that you can replace entirely with maybe FPGA. But FPGA you have then the debug capabilities that are really challenging, right? Because you have to upfront think about what you want to see in waveform. So it's not the same as an emulation, definitely not as
Maybe
in
we should do a
simulation.
session about FPGA and emulation. Well, we'll take that offline. Claudio, so let's move to AI. We can't do a chapter here without talking about AI.
Right.
What do you guys do with AI today? And I guess what do you do? What works? What doesn't work? Because we do see a lot of hype. Everybody's talking about AI. Would love to understand what's working, what's still in the works, and what's your opinion on all those?
So I think AI is good in many aspects, right? If you think about definitely we talked about reading documents, and you can just ask questions instead of reading the full document. It's save a lot of times. The other things that I liked it because when it started I wanted to give okay, I will give you some RTL module. Please write me the functional coverage for this module. And he did it very well. He did it very well. Because I had this model before and I had the coverage already that, we reviewed it, many projects with the designers. This coverage, covers really well. And he did it 80% of the job, which is excellent, right? Imagine I could get 80% of any coverage and then complete the other 20%. I'm fine with that, right? If you save me 80% of my work, that's fantastic. The other thing is I think that we are moving forward now in progress to use it more like agents, agentic AI, right? Making agents that can take a process and do it thoroughly. For example, if you have a regression tool, right, and you can analyze the regression automatically, send you the report, tell you, okay, this is the problem here. The next thing is to connect, for example, to your signal database, read the database, understand from there which signals to extract from there, and look and tell you, okay, this is the problem in this module in the design. So to save debug time. If imagine you sleep at night, right? Your regression is running, the agent is running the regression, the other agent is taking the results, analyze them, and takes the failure, analyze the failure, and give you the first hint, even the first hint. This is the area of the design that caused the problem. If you have that, then it's fantastic. We are not there yet. It does a part of it, but it's not does it something that you can. It's accountable, but I think it's going there very fast, very very fast. It's so if you take for example automation scripts, it does it perfectly. Every script that I've written, so I'm against. Excuse me, I hope I will not. Get angry at anyone, but I do not like DA groups and stuff like that. We like to do all the verification team is doing all the automation stuff and stuff like that. So there are scripts that,
teams?
Yes. So okay. Because so we do on ourselves. So there were scripts that I did long time ago, and we run them to for some kind of things. Anyway, I took these and I generate those exactly with AI. I even didn't look at the code; it just works. And even if it doesn't work, I give the AI the script back. Please fix this scenario, and it fixes that. So it's fantastic in generating scripts, C code, C++ code. It's really doing a great job. In Verilog, it's not there yet. But it's not also far from there.
You're on the verification side, but is it helping designers write faster blocks?
I don't think it's there. But I think it do helps them with other stuff. I'm not sure I want to get into that because but I don't think it's there in terms of like, okay, let's replace the designer because the AI will write the code better. I don't think we are there.
what about regressions and coverage? I mean, getting to the coverage faster on each version that you have out. Is that working well?
So we do have something that we work with our vendor that's supposed to do exactly what you are saying. I think it's not bad, but it's not there yet. But it's going to that direction, and definitely I think that it's something that in the early 2007 or something like that, there was a company that provided something really that it takes the coverage, creates a graph, and splits the dependencies wherever there is no dependencies, it's split and it runs the test with a constraint that will cover the fastest way all the constraints that you have. So this is something that I think that the AI can do, right? Or the tools that are using AI in order to direct you to the coverage or the interesting scenarios. It can do all these kind of things. I don't think it's there yet. But I think we are not far from there. By the way, we are not far. It's a matter not of 10 years, not 2 years, maybe less than that. But we'll see.
So currently, it sounds like you're using mostly for AI to optimize productivity. You're
Exactly.
not going to
Yes.
replace the core design features or the risky technologies at this point. But
No.
coverage, if you can save time writing coverage
Yes.
code, it's not too risky because it's still coverage. It's not something that goes into the chip. So I guess my question is, so you mentioned that you had a model to compare with, so you know that the AI result is good. So what do you do if you don't have that? How do you, I mean, this is something that I'm struggling with my AI experiments. I can type a prompt on my Cursor Pro here or Cloud Code. It will generate, I just write it, a full Ethernet, whatever, block. I can also ask it to build a verification environment for me. But how do I make sure that this whole thing works?
So I don't think in the current status that we are, you can really trust it. That's the thing.
Yeah,
You have
it's a
to be
trust
able
problem.
to analyze what he generated and make sure that first of all it's complete. Okay, most of the time I think that it's not that it doesn't do or doesn't do anything. Most of the
Right.
times what I saw is it do it partially, and sometimes the holes that it's leaving, they are not so easy. So
Right.
let's say if you want to build an environment, a new UVM environment, to start with, it's excellent. It will do for you all
Right.
the stuff that you already don't want to really write the code. But you cannot say, okay, the AI took it and did all the constraints and
As you
everything,
mentioned, the ownership, I mean, you're the owner. You would
Yes.
not go and say the AI
The AI is the
didn't do it
worker.
well.
Yeah.
It's your
Currently not.
responsibility.
Currently not. But to be honest, right? I think it's going there. I don't know how much time it would take in the design area. It's a little bit behind. I see in Python and other C or C++, it's much more advanced. It's definitely there. But even in C or C++, I saw you still have to check and you still have to make sure that there were no hallucinations because it happens. Yes.
Yeah, in our world, I think the problem is worse because, or better, I mean, depends how you look at it. Because for C, C++, Python, whatever, you have so much data, around, you can just scrape the internet and get code. For Verilog, I mean, if you're the company like Amazon, maybe can do the training on its own. Intel, Broadcom, all the big names, the hyperscalers. But somebody like someone else would have to make an effort to find the proper data set.
Right.
And
Right.
you also have legacy projects that you can learn from. So yeah, it's interesting where this industry is going in terms of AI-driven design.
I guess for sure it's going that direction. The question is
Yeah,
how much time it will take to get
yeah.
to get an agent that will do the job and you don't have to check it thoroughly.
And of course, and then there's the sensitive questions about what's going to happen to hiring and the workforce in our industry. I don't know if you want to go there, Ronen, but it sure
Actually, I
is
wanted to
an
ask
interesting question.
Claudio, are you guys hiring?
Yes. So actually, I think we are still at the point when, talented people we are always looking for, and with or without AI, we are in the same, so we look, for example, like not only talented, but also with the right mindset, like I already mentioned that I think for me, it's it's not, you can be talented, but if you are not in the right mindset, it's a problem for me, right? But if you're in the right
When
mindset,
you're
then we can
saying
help you.
right mindset, you mean ownership, responsibility, making
Right.
sure that you're responsible for whatever outcome would be, and it's
You are the
solely
CEO of your
yours.
block, right?
Yeah, CEO
Yes,
of your block.
exactly.
That could be the
But
tagline here.
right, but it's not enough, right? You can have a very good intentions in life. It doesn't always. It's not enough. You have to have the good intentions and also have the ability
Backed
to
by
achieve
skills.
what
Yeah.
you exactly. So it's a combination. Yes, we are looking. It's not. We are not in any way like I hear some in the news that some companies we have stopped hiring and we are because we have AI doing the job, we are not there, and we do look for talented people. And
So maybe I'll ask you, if I'm a verification engineer, a few tips, but are you looking for experienced engineers or also juniors? And, let's just understand that, and then understand what is your expectations or tips from people that could come and work for you.
And also where they should look for the open careers on your website or LinkedIn or approach you maybe.
this is a much tougher question for me. I should have prepared to that, but in our website, I guess that's would be the easiest way, and it's always there when we have openings. Regarding your question regarding juniors or experience, so look, it depends, right? So we hired in the last 2 months like 4 or 5 junior engineers and 2 students. And on the other hand, I can tell you that if there will be an experienced engineer, right, that will come, and I think we will find something, we will find a place for him. So we are looking for talented people. Yes, I very much like juniors, and even non-experienced. Because they are very open, and they already in the era of AI and all this stuff, and you can use that.
What tip
And
would they have for, someone who's coming to get interviewed?
I think that first of all, I think that patience is something that it's really important, because if someone is coming and is expecting that in 1 month will be a verification engineer that can do everything, it's might be a disappointment, right? So you cannot gzip experience. You have to take the time, learn. You have to be curious, and you have to dive deep and understand. It's not just to get the job done, which is super important to get the job done, but you have also to take the time to understand and ask questions, and be collaborative, and know how to see and how to connect with people. It's super important, to develop your career. I think it's also, something that people, especially juniors, but it's also true for anyone that comes to a new company. He needs to get appropriate and collaborate with a lot of people. And this is why, by the way, that, when we are back in the office, return to office policy, because we believe that, cooperating and collaborating, it's not something by the way. It's super, super important. Nobody can know everything. Nobody can cover everything. And nobody, should know everything. It doesn't make sense. So that's why you have a team, and that's why you have different, people to collaborate and think together and brainstorming. And I think it's essential. So that's what I think that if someone that comes in, it doesn't matter if it's in our company or in any other company, always look to collaborate with others. Always look for smart people to learn from them. This is the best thing to learn from. It's for other people.
Uh, Thank you.
Excellent.
I think our time is up, and we'd like to thank you very much, Claudio, for your time and advice. I learned a lot in this session. So, Ilani, any last words for this chapter?
Yeah, thank you, Claudio. We know from long way back, so it's always a pleasure to meet people like you from the industry. Yeah, I really love the tagline. You be the CEO of your block. I mean, it really, of course, backed by skills, but it really kind of pins the mindset of owning a block in verification, because only the paranoid survive, right? I mean,
Right?
it's your block. You can never go. When I was back in the day when I was doing hands-on verification, it's your block, and you're always scared that some bug will slip between the cracks. So yeah, it's a good mindset. Thank you so much for
First of all, thank
joining
you
us.
guys. It was a pleasure for me. It was always fun to talk to you guys, knowing you from the past, and hopefully that we will still be connecting in the future. So thank you for having me here. It was a pleasure.
Thank you. See you in the next
Thanks.
chapter.
All right.
Bye bye.
Bye bye.